Hello everyone. Good morning. Sorry, good evening. Okay, am I clearly audible? Okay, so in today's session we are going to finish off what we started in yesterday's session, connecting our sensor node to I mean to say to ThinkSpeak Cloud to upload data over there. Okay, so we'll start with we'll continue with the experiment working with our hardware, right? In yesterday's session, you connected ESP01 to serial port to establish a communication between your serial monitor application running on laptop and ESP01 directly. Okay. In today we are going to upload an application directly on our microcontroller. So we'll host this application on microcontroller, which would communicate with ESP01 on serial 1 port. Okay, so before I share that code with you to be uploaded on your microcontroller board, I would like you to, you know, make these changes in the circuit that we built in yesterday's session. You'll have to shift wires from pin number 0 and 1 to pin number 18 and 19 respectively. Okay, so the wire that was earlier connected to pin number 0 has to be shifted to pin number 18 now. Okay, and the wire which was connected to pin number 1 has to be connected to pin number 19. Okay, so this time the communication which is going to take place between microcontroller and ESP01 module is UART to UART. Okay, this is why the wires have to be reversed or crossed over. Means RX of the module, TX of ESP module goes to RX1, okay, pin number 19, and RX of ESP module goes to pin number 18. That's it. Please make these changes and let me know once you are ready. Okay, those who could not configure their ESP01 module today, I mean say in yesterday's session, they can try it today, unless they configure their ESP module and store Wi-Fi's username and password in that, it may not work properly. Yes, Ajay.
Hi, Shvi.
Yes, Ajay.
Yesterday we had missed one presentation. You remember when you are explaining about service architecture,
Mm-hmm.
service models like infrastructure as an
Yes,
and this we did not find that presentation on LMS still.
it's not there on LMS.
No, it's only video
Okay,
uploaded. I could see only a video.
I'll check with support team, or else if you have their number with you, uh, please remind them to upload the presentation because it's with them.
Okay, okay,
Okay.
fine.
Okay. Yeah.
Yeah.
Let me drop a message to them. Okay, I'm dropping a message to them to. Okay, guys. So please build the circuit. There is no need to disturb rest of the connection. Just shift wires from pin number 0 to pin number 18, and 1 to 19. That's it. Okay, are you done? Yes, Lokendra.
Hi, Safi. This is Lokendra. So, unfortunately, last 2 week I did not join this call. So
Uh-huh.
it is so pressure for our office side. So, so
So no
did
problems.
you
You know,
uploaded
this,
all the videos or the?
yes, videos are
Sorry.
available on LMS. You can go through recorded
Okay.
sessions to perform the exercises that you missed out.
Okay. Okay.
Okay.
Okay. Okay. So, what's the today topic? Is it
Uh,
related to the
you know,
Arduino
related to
board or which one? Raspberry
Arduino board
Pi.
with ESP01, but I doubt you would be able to complete this exercise because this requires, so the hardware configuration that we did in yesterday's session. So you will have to first complete the exercises, which were performed in yesterday's session, and then only you would be able
Hmm.
to, perform the exercise that we are doing right now.
Okay. So,
Okay, so I would
hardware
suggest you
means.
to. So you do one thing, you attend the session because in
Okay.
today's session I'm going to explain the code which is
Okay.
going to be used on Arduino board to upload data on the cloud. So at least
Okay.
you attend the today's session, and then you can perform this practical hands-on exercises as and when you get time. Okay.
Okay.
Okay. Guys, I've shared this code a link to the code which is supposed to be uploaded on your Arduino board in the chat window, but you will have to follow these instructions, the instructions which are here on my screen, uh, you know to upload this code on Arduino board, and finally test the data uploading on your channel created on ThingSpeak cloud platform. At any point of time, if you need my help, do let me know, okay? Because all the instructions are here on my screen. Let me put these instructions on one side of my screen and code on the other side of screen to help you guys get, you know, a good idea, okay? Come on. Okay, so here is your instructions and this is your code. Now where to make this changes, some changes in the code. So first change that you are supposed to make here in the code is okay, the first change that you are supposed to make here is API key. Okay, in the fourth line. In the fourth line, the API key has to be your API key, which you can take from ThingSpeak cloud platform. Go to your channel, go to API key section, and copy right API key from there. Okay, and then at the bottom in the there is a function called Connect Wi-Fi. Inside Connect Wi-Fi, you will find 1 plus 3. So you will have to replace this 1 plus 3 with your SSID and 876543221. This is password of my Wi-Fi router. So you will have to replace this password with your password. Only these 3 changes, okay? So you take the code from here, paste the code in your Arduino IDE window. Okay, do not forget to delete those loop and set up functions from there. Okay, because this entire code will have to replace everything in your Arduino window. Once pasted, take the API key and from the ThinkSpeak, put it in the 4th line, make the changes, SSID and password, and then upload your code on Arduino board. Now, once your data start flowing from your Arduino board to cloud, I'll walk you through this code to understand the logic. Okay. SSID is your SSID, Surendra. Your Wi-Fi router's name. Rakesh, yes, we'll perform few more experiments, you know, on ThinkSpeak as well as on AWS. Raj Surya, you can contact our support team, you know. What kind of problem you are facing? Could you please use audio mode to talk to me? Raj Surya?
Hello?
Yeah, what is problem
Yes.
being faced by you?
Hello?
Pardon? Yes, please.
Yeah, actually, yesterday I told na the LED is not working. I feel that only LED is not working. But what happened that yesterday itself it is not configured. And the board is also a little bit getting heat.
Okay, so did you make sure that your the power supply connections you
Yeah.
connected to 3.3 volt?
I should and I connected. Then only I feel that it is misbehaving.
Okay, no props. You please contact our support team. They will help you, you know, getting this hardware problem rectified. Okay.
Okay.
Okay. Okay. That's it.
Thank
Okay. Yes, Lokendra.
Safi, could you please, if it is possible, could you please let me know about the diagram so that I will start the same.
But you know, before making this diagram, you will have to make another diagram to configure your ESP01 module. Unless you configure your ESP01 module, you know,
Mhm.
this exercise, the exercise we are performing, will
Mhm.
not work.
So, if it is possible, could you give me some basic idea so that I will start the performing
So,
this exercise?
so what we are doing, we are uploading data on ThinkSpeak
Mhm.
cloud platform. You remember ThinkSpeak in last session, we created a
Mhm.
channel on ThinkSpeak. Did you attend that session?
Yeah, that's the reason yesterday I did not attend the session.
No, not yesterday's. In the last week,
Last week
we
Sunday,
created.
last week Sunday, last okay. Mhm. Last
So
week
we
Sunday and Yeah, I missed that session.
Yeah, so you should have gone through the recorded sessions, Loken, because you will have to complete all the exercises in the given sequence. So first
Okay.
in last week's session we learned how to create a channel on ThingiSpeak. Once a channel has been created, then the exercise that we are performing today is to upload data on the channel created earlier. Okay, so
Mm-hmm.
you'll have to go step by step. Uh, you cannot miss, you cannot skip the sessions. Getting the idea?
Okay, yeah, yeah. Yeah, it is some emergency. That's the reason I
No, no,
skipped
I
that
understand,
session.
but we have a facility. We have
Mhm.
a facility. We keep all the recorded session online to help those who miss the sessions. So I would suggest you to go through recorded sessions. If you face any difficulty, first you attend those sessions and then you discuss because repetition wouldn't possible, right? These
Yeah,
are
right.
these are lengthy exercises. This consumes lots of time. So I'm afraid, I won't be able to repeat the exercise. I'd suggest you to go through recorded session and then, whenever we find time in the next sessions, we can have discussions on them. Okay?
Sure.
Sure. Okay. Yes, Ajay Kumar.
Um, Shafi, this once we configure that ESP01 board,
Uh-huh.
and when we remove power and connect it back, does it retains the configuration or do we need to
It
reconfigure
does. No, it
on?
returns the configuration.
Okay, it stores in NVM. Okay,
Yes, it stores the last configured SSID password in its memory.
okay, okay, thanks.
Okay. Yep. Sagar, what is the problem? What is the problem? Could you please help me understand? Yes, Sagar.
So, sir, hello.
Yes, please. What is the problem?
So, when I'm connecting my module, right? So, ground and the VCC.
Uh-huh.
So, in my module, this blue LED continuously glows up, right? So, it doesn't goes off. So, but when I was watching your video yesterday, and I have referred some videos on YouTube as well. So, it's the only red LED that goes on when we power out, when we power up the this IC,
Yes.
right?
Yes.
But so again that problem is continuously coming in that when I open the that thing where we write 80 and all, right? So I'm not getting anything, and so this is the
Did you
problem. And
did
one more thing is that whenever I connect because VCC power has to give into two pins, right? One is CHPD and one is VCC, right? So
right?
whenever I give power to CHPD as well, then
Mm-hmm.
also the blue light continuously goes on, right? It doesn't goes off, and there are
See,
some unusual strings which
CHPD
continuously
CHPD is the third pin. CHPD is third pin. Can you please make it show that you are connecting to third pin from the VCC side?
yes, I have continuously, I have checked these connections a lot of times since morning. I
Mm-hmm.
am doing all these things.
Mm-hmm.
I'm trying a lot to, I've referred a lot of
Okay. So it
images on
means it
Google
means there is
Google
something.
Images and a lot of videos as well.
There is something seriously wrong with the ESP module.
Right. So I have
Uh,
contacted support as well. So they replied me that your inquiry has been transferred to your trainer, and
okay.
he'll get back to me. So
So
now I don't understand.
you do one thing. You talk to them and explain them that it's a hardware problem. It's not a technical problem that had to be resolved. That has to be resolved by trainer.
I have mentioned everything in the mail that I am telling you right now.
They might have missed it. I would suggest I'm suggesting you to make a call, Sagar, rather than dropping an email. Directly make a call to them. Okay.
So is there any number which we can call on support?
That number has to be with you because support team do share all their contact details and other things with participants.
I'll check that in the mail, sir.
Yes, please, please. Okay.
Thank you, sir. Thank you. Yeah.
Uh, yes, Srinivas. Srinivas Prasad. Okay. Yes, Rakesh.
Yeah, Shafi, with regard to the support, with respect to the support team, this is really not good because we have been routed to
See,
multiple people.
let us not talk about this in during session, Rakesh. Because I'm a trainer, right? My job is to deliver the
Shafi,
tool. So,
You see, here you need to understand when you say us to contact support team, whom I need to contact. If you can tell me the name of the representative, that would be more
uh,
better because
the
you
the
are a trainer.
manager,
I am a participant, so I
I understand.
expect, yeah, so I expect some level of support here because see, it
Okay,
cannot be done
so
on.
let me share their names, Rakesh, because uh, I cannot help you during session. You understand my
No,
problem?
I
That
totally
20
agree.
20 plus
But
participants.
somebody has to take responsibility with respect to these things because these
So
are more critical.
I'm telling you the name. Please call them and talk to them. The
Yeah, please
team
tell the name as
lead
well
is,
as the number.
see, this is not the way you can talk to me, Rakesh. Please
So that's
understand.
what I'm
Try to
saying.
understand my problem.
Reason being, I will show you. I have sent so many emails and I have made so many calls, but nothing had been arranged from support team. And
So,
finally, like the workaround was that the person who is point of contact, he is on leave. So I really don't
Rakesh,
know what.
we see, I cannot lose my time in this discussion. Please take the name. Number has to be with you guys, and then you talk to them. Okay.
Fair enough. You
The
give the name. I try to
team
reach
lead is
out to them
Sachin.
on Monday. Ah,
Would you please listen to me?
yeah.
Team lead is Sachin. Okay, and the operation manager is Radha. You please
Fair
call them,
enough.
talk to them, and let us avoid discussing these things during session. Okay, please.
Sure enough. If we get the
Yeah,
required
because
support, we will contact.
as a trainer, my job is to focus on the delivery, not
No, I
on
totally agree.
sorting out.
Definitely. I am also from training background and I have worked as trainer as well. So I really know
I
what is your jobs and responsibility. But the thing
I
here
understand
is we
that thing,
need to
Rakesh.
work in a connected approach. So when you guide me to someone, he should not keep me in that loop
Rak-
for a long time, correct? There has to
Rakesh,
be some responsibility.
discussing this matter with me will not fetch anything. Please. I've shared name with you. Their contact numbers
Fair
are with
enough.
you.
Let
Please
me talk
contact
to them
them.
on
Drop an
Monday.
email to
Let's see
them.
what happens. Yeah, let me talk to them on Monday, tomorrow
Okay.
itself.
Thank you, Rakesh. Thank you. Yes, Jitendra. Jitendra, I cannot hear you. Jitendra, please check your audio. Srinivas and Jitendra, both of you need to check your audios because I'm not able to hear you guys. Please drop your message in chat window. Any problem that you might be facing. Uh, okay. So guys, are you done with this thing? Uploading code on your Arduino board? If you're done, let me show you what you are supposed to get in your serial monitor window. I'll show it to you. Okay, so Chandrasekhar and Jitendra have completed this exercise. Let me show you, how this code, what messages this code shows in serial monitor. So in serial monitor, you will see these messages. Okay, in serial monitor, you will see the final message you're supposed to get is connected to cloud. If it shows connected to cloud, it means your data is getting uploaded. So those who are getting connected to cloud message in their serial monitor window after following all these instructions, please go to your channel, and on your channel, in on your channel that you created inside the chart, you will see the values getting uploaded over there. Okay, if you connect your temperature sensor to A0 pin the way we did in one of the exercise earlier, you would see actual temperature values will start getting uploaded on your channel. Good. Okay. Should I explain the code being used by us? Okay. So let me let me walk you through the code which is running on Arduino to upload this data on cloud. Okay, so let me take code directly from this link, because this is the code which is being used by you. Okay, so I'm taking this code. Let me open a new window, replace everything with the code. Okay, so here in the code, the first line, as you see here, is int LED pin 13. Okay, int LED pin equal to 13, and this line is to assign. I'll put comments here. Okay, what are we doing over here? This line is to assign LED pin name to pin number 13. Okay, so we are assigning a name to pin number 13. The next two lines, let's say this line is to create a floating point, variable j to hold sensor data. Okay, whatever sensor data we will capture from LM35, we are going to store it in this variable j, which would later on be uploaded on cloud platform by us. Okay, so j is going to hold temperature data. Srinivas, there is no need to generate API key. You simply go to your Thinkific cloud platform, thinkific.com, the channel you created earlier. In the API keys section, in this tab, private view, public view, channel settings, sharing, API key section, you will find your right API key. And if you remember, I did, explain you, these keys are used for authorization. Okay. Got it, Srinivas? You can take this key from here. There's no need to generate a new key. Take the existing key from there and put it in your code. Okay. But before you do that, please pay attention, because I'm explaining code to you. Okay. Okay. So here in this line is to assign a new name sensor to A0 pin. I'm just putting this comments to help you understand the code. Okay, this is API key to get our request authorized on Thinkific cloud. Okay, so this API key over here is to get whatever, when you send the HTTP request from here to cloud, your request would be accepted by cloud only when this key is a part of your request. Okay, I did mention the format of requests that is supposed to go to cloud, right? This is the format. We tested it manually, right? So this is the format of the request, following HTTP protocol, and this is what cloud would expect from us. And this is the API key. So API key has to be a part of the message, right? So in our code, we'll use this API key mentioned here to create the message, which has to be submitted to cloud platform to get our data uploaded over there. Okay. Now moving onwards, here in the inside setup function, the first line is to, and right, you're familiar with the with these functions now. The first line is to, this line is to define mode of LED pin is output, right? Pin mode function. Pin mode function is called to define mode of the pin. Then we have serial.begin call. We are calling this method, begin method, to initialize serial communication port. Now, which one is serial communication port? The port connected to our laptop or PC, the blue cable or black USB cable, whatever you're using. That is the port, which is getting initialized over here at a bit rate of 9600 bits per second. Okay, so this communication will take place between microcontroller and PC or laptop, whatever you are using. Our ESP01 module is connected on serial 1 port. Okay, and ESP01 is factory configured, to make a communication with 11.5200 bits per second rate. Okay, so this is the reason why we are initializing serial 1 port. Serial 1 port means pins 18 and 19, where our ESP module is connected to, right? This port is called serial 1 port. Okay, so this port has been initialized here by calling this method, and then we move forward and call this function connect Wi-Fi. Okay, see, connect Wi-Fi function is being called inside setup function. Okay, now let us look inside the connect Wi-Fi function, because this is being called here inside setup function. It means connect Wi-Fi function is going to be called when you switch on your microcontroller. Okay, let us look at inside the connect Wi-Fi function definition. See, okay, here this is our connect Wi-Fi function. Okay, the first line in connect Wi-Fi function is AT plus CW mode equal to 1. You remember this line? Yesterday we sent this command manually to ESP01 to configure ESP01 or to configure ESP01 work in station mode, right? As a client, station mode. Okay, Sarthak has a question. He says, can this exercise perform in Arduino Uno as I've given my Mega? Okay, yes, you can, but you will have to define one, a group of pins is software serial port, Sarthak. Okay, I'll help you do that. Just hold on. Let me first complete this code. Okay, complete the explanation of this code. Okay, so this, see, we are sending this message AT plus CW mode equal to 1/r/n. Why /r/n? Because AT command protocol says that AT commands has to be ended with /r/n. In yesterday's session, we selected both NL and CR as line ending operation, right? So both NL and CR means inserting line ending and carriage return signal at the end, which is being done here in the code, by appending this to special characters, at the end of our AT command. Okay, Shivani, what is your question? Okay, I'll resend the code link. Shivani, could you please first attend this explanation? Okay, let me complete this explanation and then I'll share the code link. Okay. Okay, so once, see, this command, when you send to serial 1 port, and since our module is connected on serial 1 port, it means module will configure itself as a station. Okay, in the next line we are creating a string. See, string name is CMD, and this string is AT plus CWGAP command, and then we are appending SSID name and password to it. Okay, so CMD string, once you complete this thing, or once you execute all these 5 statements, your CMD string will be ready, and CMD string will have this inside it. Okay, AT plus CWJAP equal to your SSID. In this case, SSID is 1 plus 3, comma, the password. And in this case, password is this, right? So this is what CMD string is gonna hold, you know. So this 5 instruction will result into a CMD string with /r/n at its ends. Okay, and then here we are sending this string to serial monitor as well as to ESP01. Okay, and why are we sending this to ESP01? To connect ESP01 to connect ESP01 to specified SSID and password. Okay. Yes, Ajay.
Shafi, this function does not check the response from the ESP01 OK response. I think it is better.
Okay, we can insert some code here to check the OK response.
Yeah.
Yeah, we can do that.
Okay.
But you know, it's not needed because we have already configured it manually, right? So if needed, we can insert a code over here. Yep. Okay.
Yeah.
Okay. Rasuria, what do you want me to do? Rasuria.
Yes. One more. Actually, hello.
Yes, please. What do you want me to do?
Instead of splitting the lines, writing in a single command is better understanding. That's my suggestion. What you are writing, AT plus CWJF equal to the SSID and password and the new line and new character, second line.
Okay, so you want all this to be written in a single line, right?
In command line, that is what you are commented, na?
Yes.
Yeah, that is gives a better understanding to everybody. That is my just suggestion only.
Okay. So either you do this, and because the goal of writing these 5 instructions is to build this CMD string, right?
Yes.
Which has to be delivered to ESP01 to connect ESP01 to SSID or to SSID specified here.
Yes.
Okay, guys. So this code segment from this line to this line is responsible to connect ESP01 to specified SSID and password. Rakesh, yes, Rakesh, the commands AT command, it's AT command protocol, and we how to send command is specified in the document provided by the manufacturer, right? So ESP01 is manufactured by ExpressIf, and all the instructions command formats which are being used over here are suggested by or recommended by ExpressIf. I shared a PDF document in yesterday's session which contains a description of all the commands which are being used by us in this session, or even in this thing. Yes, so AT commands would vary from module to module, from manufacturer to manufacturer, right? Because it's firmware, the program, which is built in that hardware, the program's responsibility, the firmware's responsibility is to interpret the commands, and it all depends on the coding done by manufacturer, right? So I'm not doing anything. I'm just using command is specified in the document provided by manufacturer. So every time you're working with any module, you will have to refer to manufacturer's documents and datasheets to make your hardware work, right? Okay, guys. So once you have connected your Wi-Fi module to your SSID. Then here I have inserted a delay of 10 seconds, to just wait for our module to get stabilized, right? Once it is stable, then in the next step, we are sending a command, serial1.print. The command is AT plus CWJP ? Okay. And this command, if you remember, when we send this command, our module responds with plus CWJP, then SSID name, and then SSID's MAC address, right? Or Wi-Fi router's MAC address. Here in the next statement, I'm not actually comparing entire string. I'm just looking for this substring in the response that might have come back from ESP01 module in serial1 buffer. Okay. See, find command or method checks in the buffer for the availability of a substring given to it. Okay. So we are telling we have written this instruction over here to find plus CWJP in the buffer as a part of response to AT plus CWJP ? Command. If your module responds with plus CWJP ? It means it's properly connected to that connected to internet, or the SSID provided by you. Okay. If this results into true, if this find function returns true, this two lines will execute. The first line will print OK connected to Wi-Fi in the serial monitor window, and then it returns back to setup function. If this find function doesn't return true, if it returns false, in that case, this code under else clause will get executed, and you will see cannot connect to Wi-Fi message in the serial monitor. Okay. So anytime if you see here, let me restart my module. Okay, I'll just reset my Arduino board, and you will see connected to Wi-Fi message. Okay, so it sends this AT plus CWJP, my SSID name, SSID password to my module, and my module has to respond with connected to Wi-Fi. Oh, something wrong? Maybe some loose connection. Okay, it was working just now. Anyway, so just a quick test, right? So if you see cannot connect to Wi-Fi, it means there is something wrong with the Wi-Fi connectivity. If it says connected to Wi-Fi, it means Wi-Fi connectivity is there. Okay, it means there is something wrong with my Wi-Fi connectivity. I will have to check it. Okay, so this is what connect Wi-Fi function is doing over here, right? Connect Wi-Fi function. If you look at the instructions contained in connect Wi-Fi function is responsible to configure your module as a station and then connect it to a given SSID and then verify the connectivity and print a message on serial monitor whether it's connected to Wi-Fi or not connected to Wi-Fi. Okay. Once this is done, our control will roll back to setup function, and then once this is done, we'll enter into loop function. Okay. Now, what is going to happen inside loop function? Let us talk about that. Okay. Who was raising the hand? Yes. Yes, Ajay.
Shafi, in that connect Wi-Fi function, when we are sending, can you go down to the function? Yeah, when we are sending AT plus CWJAP ? Okay, and then immediately you're waiting for the response. Okay, I think we have to insert some delay between these two so that the module send the response, it comes to the Arduino. Then I think you will not get that message not connected to Wi-Fi.
I did receive connected to Wi-Fi earlier.
Yeah, because it works. To wait for some time. Because as soon as you send the command, so the data is coming serially, whereas your processor is executing at very high speed. Before it
Okay, fine.
appears to your
So
buffer, maybe a few 10 milliseconds or maybe 20 milliseconds.
no props, no props. So let us do that. Okay, I'll make it a part of the my code itself. Let's insert a delay of 100 millisecond. That wouldn't make a difference, right?
Yes, sir. Even if it
Okay.
works in 900, very different baud rates also.
Pardon?
This correction may help in working with lower baud rates also.
Okay, fine, no problems. So I've inserted a delay over here, and other participants, if you would like to make it work as Ajay suggested, we can insert a delay of 100 millisecond to allow your, it's not exactly here, after this command, right, Ajay?
After sending, yes, there. Before if,
okay,
yes.
Okay. Before if. Okay, good. So it's always good to delay the processor because obviously it would run faster than the peripherals, right? ESP01.
Yes.
Okay, thank you. So guys, as Ajay recommended, it's good to insert a delay. I would suggest all of you to, if your work module is working fine, it's good. If not, you can insert a delay of 100 milliseconds over here. Okay, after your this thing. Anyway, I will have to cancel it because anyway, let it get uploaded. Okay, sure, Rakesh, I'll create a pagement link of this. Okay, so this code over here, and I'll put the command over here. Code or following code is to verify connectivity of ESP01 module with Wi-Fi router. Okay, so from here to till end, this code segment is for verification of connectivity. Okay, to compensate, you can do one thing. I would suggest you guys to reduce this delay from 10 seconds to let's say 5 seconds. This is not going to make a difference. We can reduce the delay over here. 5 seconds is good enough, to allow module to establish connectivity with the SSID. Okay, so this is what connect Wi-Fi function is doing. Jitendra will sort out. Let me first get done with the code, right? And then I'll help you guys with rectifying those problems. Just hold on, please. Okay, guys. So let us get into loop function. See, inside loop function, the first line analog read sensor, and you remember, in ADC section, I did explain the logic behind these 3 lines. Okay, the first line is to read a digital data coming from ADC, right? And this digital data would represent the digital value of sensor's output voltage. Okay, ADC's job is to convert analog value into digital value, right? So this digital value is getting assigned to this variable val, and then we are multiplying val by 5000 and dividing it by 1023 to convert digital value into sensors voltage in millivolts. You remember that? And then here we are dividing this value by 10 to convert sensors voltage in millivolt into degrees Celsius, right? So finally, temp C will hold our temperature value in degrees Celsius coming from sensor to A0 pin. Okay, and here in this line, I'm assigning this value in to this variable j. So j will hold temperature in degree Celsius. Okay, value. Good. So this is what this is holding. And then here in the next 3 lines, what are we doing? In next 3 lines, these 3 lines are just to blink the LED. Okay, these 3 lines are there to just to make the LED pin high after 500 millisecond, to make the LED pin low. Just to indicate that yes, a sensor value, a data value has been captured. Okay, which is assigned to J. Now, once this is done, our next job is to upload this data on the cloud platform. The Wi-Fi connectivity is there, temperature value has been acquired. Now, next thing is establish an end-to-end TCP/IP connectivity, as I explained in yesterday's session. Yeah, so we'll have to start a TCP/IP communication session now. Okay, and the session is being initiated by giving this command AT plus CIP mux equal to 0. Okay, this command will configure, to configure ESP01 module work in single channel mode. Okay, so we are configuring this ESP01 module as I explained it to you in yesterday's session. Mux means multiplexing, IP multiplexing. Okay, so instead of setting up multiple streams of communication with server, we are interested in setting up a single channel communication. So assigning a 0 to CIP mux means disabling multiplexing. Okay, I have inserted a delay of 1 second to allow ESP01 to configure itself, and then next code over here up to this point is to establish following code is to establish TCP connection with server. Okay, and you remember the command for that is AT plus CIP start. Yesterday we sent this command to Google server. Okay, today as you can see here, we are preparing a string, and instead of domain name I'm directly using ThinkSpeak Cloud's IP address. Okay, so this string, CMD string, again the string name is same, but string is different. After executing this group of commands over here, CMD string would be AT plus CIP start equal to double quote, and inside double quote TCP, and then comma, IP address of ThinkSpeak IP address is 184.106.153.149, and then there is going to be a port number 80. Okay, so once this string is ready, we have to send this string to serial 1 port. Why serial 1 port? Because this is where our ESP01 module is connected to. Okay, so we are sending this CMD string to ESP01 module. Now what ESP01 module will do? Once ESP01 module receives this string, it will establish a transport layer connectivity end-to-end with the server, with ThinkSpeak server, right? And this transport layer connectivity will be used by our application to talk to an application running on ThinkSpeak Cloud. Okay, so, and just for our knowledge, this string is also getting printed on serial monitor. Okay, so I'll put a comment over here to serial monitor, just for our knowledge. Okay, so this is kind of like JFYI, just for your information, right? We have inserted a delay of 5 seconds over here. we can reduce this delay to 2 seconds or 1 second even. Okay, but anyway, let's skip it. See, in case if a TCP IP connectivity cannot be gained, your ESP01 will send an error message back to microcontroller. Okay, and that error message will get stored or will be available in the buffer, serial 1 buffer. Okay, so this is why after a delay of 5 seconds we are checking serial 1 buffer and checking the checking this substring, checking for this substring error, in a message or response that might have come back from ESP01 module. Okay, if there is an error in getting a TCP connectivity established, this condition will become true, and you will see a message serial. Or you'll see a message on your serial monitor, AT plus CIP start error. Okay, or let me make this message simpler. TCP or transport layer connectivity. Transport layer connectivity can't be established. Okay, I'm just making this connection simple. See, if you see this message, transport layer connectivity can't be established, it means there is something wrong with the network, and because of that your ESP01 module is not able to reach to server. So the problem may be with the IP address, or the problem may be with the network availability. Okay, so if you guys receive this message, transport layer connectivity can't be established, earlier in the earlier code that is with you, this is AT plus CIP start error. Okay, so if in case of this error, I have uncommented this return line. Your microcontroller will go back to the first line of loop function, and it will restart the process of capturing data, and then again it will try to upload the this on server by establishing this TCP IP connectivity. Okay, let's say if server does if your ESP01 module doesn't return this error message, if TCP connectivity could be gained easily with the server, our microcontroller will move forward. It will come to this code, and what do you see over here? We are preparing our final message. Now, what is final message? Okay, we'll prepare final HTTP message. Okay, I'm just commenting it. Following code prepares final HTTP message to be delivered to server. Cool. And as you can see here, the final message is a GET request. Okay, HTTP request. GET is the keyword, and then a path, API key has to be there. Field 1, J is our data which has to be uploaded on cloud, and then the command must end with /r/n. Okay, so final string would be this final string would be, let me put a comment over here. The final string get str would be there is line ending. Okay, so get str would be get space /update API API underscore key, your actual API key that you specified at the top, the value of API key variable, ampersand, which is a separator, field 1, okay, equal to J. J will hold that value /r/n/r/n. /n. Okay, so this is your final string, which would be prepared after execution of this group of statements over here. Okay. Vishal, AT commands has to end with /r/n. Okay, this is this command formats are recommended by manufacturer. Please go through the document that I shared in yesterday's session. Okay, quick start guide of ESP01. Rakesh, field 1, yes, exactly, yes. This field 1, refers to or represents the field 1 we created over here on ThinkSpeak Cloud. So whatever you assign to field 1 over here, that is the value which is going to be uploaded over here on your channel. You see, and if you look at the API request provided by Cloud, don't you see this thing? This is the format that we have taken from here. So get str we are preparing here in our code is actually the format recommended by ThinkSpeak Cloud. Okay, we are supposed to send a message to them in the format given by them, right? Yes, Ajay.
Shafi, don't we need to send the whole URL, including HTTP, everything together?
Yep. Why are we not doing that? Because that host level connectivity has already gained transport layer connectivity, right? See, while establishing transport layer connectivity, we already specified host name or IP address.
Okay.
Right. So transport layer connectivity is already there. This is why there is no need to specify host name once again here in the get message.
Okay.
Right.
Fine.
Yes, Rachurya.
Yeah. Is that field 1 is it our what name we are specified in the that web URL that we have to mention or anything?
Field 1 has to be field 1 because this is the format recommended by the cloud. Can you hear it?
No.
See, look at the format here. It has to be field 1.
Okay. Okay.
Format is one over here. We are sending the message is expected by the cloud. Look at the format here.
Okay.
Right? Okay. Guys, just hold on. Let me open this quick start guide. Rakesh, just give me some time. I'll share the document once again with all of you to share the format of commands. Okay, just hold on. I'll get back to you later. Let me first complete this explanation of the code and then I'll answer the question. Okay. So guys, once this is done, once our message is ready and this message which is expected by cloud is stored in this string get str, right? But before we send this get str to ESP01 to be handed over to the router, as I explained in yesterday's session, right? So before we hand over this get str to ESP01, we need to send its length. Okay, so first you will have to send length of your message to ESP01, and then once ESP01 responds with this prompt, then you can hand over your message to it. Okay, so we prepared the string over here, and then just printing it on serial monitor. Okay, so again this is JFY, just for your information, and then here in this 3 lines we are preparing a command cmd string. Now what is the cmd string going to hold? Cmd string will hold AT plus CIP send equal to length of get str string. Okay, now how are we calculating length of get str string? We are calculating length of the get str string by calling length function. Okay, length function will return length of the get str string, and this is getting appended to this command over here, right? Yes, Rakesh.
Sir, what I understand here is when you are saying this AT plus CIP send, or in the previous part, there is a small catch here. You have mentioned this simple compound assignment wherein CMD plus equal to string get string dot length. So how come you are writing this AT plus CIP send equal to length of get string, wherein it is actually getting appended? So why there is this equal to
Okay,
sign?
sorry,
And
sorry. No. So this has to be,
even the
inside
same thing
quotes.
happened in the previous case actually. If you go
Pardon?
to the previous line which you were explaining, can you please go to the previous section of HTTP?
Yes.
See here also you have mentioned API underscore key equal to API key and field 1. So that should not be equal to here as well within the
Why?
comment, because that will
Why?
actually change the meaning.
No. Equal to is there, a part of this string, right? Equal to is a part of this string.
Okay, so here it is part of it. Okay, then it's fair enough.
No,
So
here I
equal to
forgot
J.
to put here I forgot to put this double quotes.
Okay,
This
then it's fine.
this is inside double quote. This is our string, which is being created with this name CMD, right?
Okay, then it makes sense.
Okay. Yeah. Thank you to point it out. Okay, guys. So here we have the CMD string, which holds the length of our this thing with /r/n and as line ending characters. Okay, and then here we are, sending this string to ESP01 to tell it, yes, this many bytes have to be communicated with server. Okay, so it will prepare itself. This is to send to ESP01, and the next line we are also sending it to serial monitor just for our information, JFY. Okay, after a delay of 5 seconds, we are looking into buffer of serial 1 port. But if buffer contains this character, this is the prompt. And remember, in yesterday's session I showed everything to you using this commands manually. Okay, so as a response to AT plus CIP send command, ESP01 returns this prompt. If ESP01 returns this prompt, it means the server's connectivity is there. ESP01 is connected to cloud, and cloud is waiting for our message. Okay, so here if this prompt is there in the buffer, it means this condition becomes true. If a statement becomes true, and you will see this message printed on serial monitor just for your information that there is connectivity with the cloud. And ESP01 will here, once there is connectivity, will send our get str to ESP01 to finally to be delivered to cloud. Okay, so as you can see here, the get str message we prepared here, get str, you see this message, right? The final message, this message is being handed over to ESP01 in this line. Okay, final message handed over, okay, over to ESP01. Okay, so once you hand over this message to ESP01, then it's ESP01's responsibility. The transport layer running inside ESP01 would be responsible to deliver this message to cloud server, right? If in case if this prompt does not return, okay, the code here inside else clause will run. Okay, so the first line is to send a command to ESP01 to close TCP/IP connection. Okay, we'll kill TCP/IP connection, and then we'll send a message to user. Message can't be delivered. Message can't be delivered. To cloud. Okay, I'm just making it simpler for you guys. Okay, then once this is done, so either your message will go to cloud or it won't go to cloud, right? This if else block is for that. If you see this message connected to cloud, okay, so let me make this message meaningful. Connect to cloud, message delivered. Okay, if you see this, it means your message has been delivered. If you see this message can't be delivered to cloud, it means there is something wrong with the connectivity. Okay, then after a delay of few seconds, okay, after delay of 16 seconds, so 16 seconds is the limit set by ThingSpeak. Okay, ThingSpeak, just to avoid getting their cloud platform flooded, they have put a limit of 16 seconds between consecutive requests. Okay, so next update, next data, you can only upload after 16 seconds. So I have inserted a delay of 16 seconds over here. Anyway, we can reduce this to few more seconds, because our code has lots of delays inserted between lines, right? So you can make it 10 or 12 seconds. That won't make a difference, but anyway, let's keep it 16 seconds, right? So after 16 seconds, our loop function will repeat. Okay, from here we'll go back to first line, capture the next value, store it in J, and then we'll follow this entire process once again to upload our data on ThingSpeak Cloud. Okay, I hope this entire code is clear to all of you. What I'll do, I'll create a new Pastebin link, okay, to share this commented code with you. Okay, just hold on. Yes, Ajay.
See, once we send this temperature data to the cloud, and then cloud will return a number, transaction number, I think so. Right? So,
yes, it
what way we can get
number
this
of entries.
Entries. So, is there a way we can get that number to our Arduino board?
I think we can. Let me think about it. Just hold on. Let me first create this link.
Okay.
Because ESP01 does wait for a message to come back from cloud, and if we cannot, if not with ESP01, at least with the other module we are going to use for our future exercises, Node MCU. That module can help us doing that.
Okay, fine.
Okay. So I will have to try that thing, Ajay. It's good that you are asking me to do that, but I will have to modify my code to.
No issues. You take your own time.
Yeah, and then print it here for our information, right?
Yes, fine. So it will give some more knowledge about the complete loop going and get.
Right. So once you submit the request, and we did this manually, right? When you manually submit the request, cloud sends number of entries. Yeah, that we have made on.
So that we can print that number of entries on the serial monitor. So it will give the complete understanding of the loop.
Sure, I'll work on my code and we'll try to incorporate that feature.
Yes. Thank you.
Okay. Okay, guys. So I have shared commented code in the form of a link in the chat window. Please take that code if you want to test this code on your system. I mean to say with your hardware, you can do it. Okay. Okay, we have question from Chandrasekhar. He says, since ESP01 module runs a full network stack, is this implied that the TCP layer stack takes care of retransmission if it does not get an acknowledgement from the server? TCP, let me think, Chandrasekhar, because here in application we cannot make any provision. We did not make any provision for retransmission, right? So it all depends on transport layer, and it's only transport layer which would take that decision, right? So we'll have to refer the documentation of ESP01 to find this out, whether the transport layer available on ESP01 retransmits the message if the message is not accepted by the transport layer, the peer transport layer on the cloud platform. So we'll have to check its documentation for that thing. But anyway, I'll keep this question saved with me, and we'll get back to you most probably in the next session. By after referring to this manufacturer's documents. Okay. Okay. Okay, LM35 you can easily connect Jitendra, the way we did in the last session, you remember? This is how we connected LM35. You take 5 volt ground and this. Okay. So once you connect LM35, actual temperature value will start flowing from your Arduino board to ThinkSpeak Cloud. So Jitendra, 80 plus CIP start error, it means there is something wrong with the network connectivity. I suggest you to reset your module and retry after some time. As I just explained, 80 plus CIP start error. And why don't you do one thing? Why don't you try with the new code that I shared in the chat window? Upload the new code. You'll get a better visibility or whatever is going on inside your module. Okay. Guys, just hold on for a few seconds. I'm looking for the document that I shared with you in the yesterday session. I will have to. Yes, Chandrasekhar, just looking for this format of 80 commands. How many /r/n have to be appended, because all this have to be a part of the datasheet or document provided by manufacturer. And it says correct line endings should be carriage return only for default firmware versions. But anyway, it doesn't work. If we only put carriage return, one carriage return, it doesn't work. So it has to be /r/n, but 1 or 2, that is still doubtful. Anyway, I'll go through the document once again to find out, because Rakesh is interested in knowing how, why, or who was there. someone dropped a message, y2/r/n. So it's all part of the the documentation provided by the manufacturer. Anyway, so what I'll do, rather than wasting time now, let me do it, post session, and I'll share whatever I find out from documents with you in the next session. Okay. Shahrukh, you will have to follow the steps that I have provided to you. Check your hardware connections. Make sure you have made right connections, and your ESP01 module is configured properly, to be connected to your Wi-Fi, and then upload the code that I have shared with you. Okay, guys. Sorry, almost 1.5 hours. So let's do one thing. Before we jump to new topic, I'll give you some time. Okay, Sarthak, yes, just hold on. So Sarthak, in your program, you will have to call, you will have to include a library called software serial.h. Okay. You'll have to include this library, and then you can call, you can call this function to convert, to define a port serial 1, and I think you will specify pin numbers. So you can use pin number 10 and 11. Let me verify this. Anyway, this is how you can convert your pin number 10 and 11 into. You can choose, two of those digital pins to be converted into software serial port, because you need 2 serial ports, right? So just, okay, I'm sharing an example with you. Okay. So here is the example, right? As I just did. You add, so for example, here your pin number 10 will act as RX pin, pin number 11 will act as TX pin. Okay, so please add this line, the line that I've written over here. Pin 10 is RX, and pin 11 will behave as TX. Okay, so this will be your dummy serial port. Keep rest of the code as it is. Just add this line. Okay, and this is only for Sarthak. Okay, not for other participants. Hopefully it will work. But be careful with the connections. The modules TX must go to pin number 10, which is going to act as RX, and modules RX must go to pin number 11, which is going to act as TX. Okay. Yes, Jay.
Shafi, that double /r/n and again /r/n is needed, because I think when you get the command prompt, okay, a single /r/n will work as a notepad enter, like /r/n does not end of the command. It will allow you to enter the next line of message, keep on maybe 3-4 lines of message. A single /r/n may allow you to go down to the next line, not the end of the command. After getting the prompt, not at the AT command level. I think after getting the prompt, you need double /r and /n in order to end the message.
Okay, so you meant to say with prompt, we need 2/r/n, right?
Yes,
To
because
end the
one
command.
/r/n will, yes, one /r/n will go to the next line of the message to enter the
Okay,
extend the message.
okay, got it. Thank you, Ajay.
I think so. Yeah.
So, yeah, so other participants might have understood this logic. Ajay just explained, the /r/n, why we are putting two here in this get string. Because one is to go to next line and second one is to end the command. Okay. Thank you, Ajay. Okay, guys. So we are done with this exercise of uploading data on cloud. For those for whom it's not working, don't get disheartened. What you can do, you can contact us on weekdays. We can help you sorting out hardware related issues, and we'll help you make your hardware work. Okay, so please contact on Tuesday. Don't contact on Monday. Contact on Tuesday onwards on any weekday to get any help from support team to sort out hardware related issues. Okay. Srinivas, once again, I'm telling you, please check your connections. If you are those who are getting some problem, code is a tested code. It's been working with other participants. There is nothing wrong with the code. The only possibility is hardware connection. Yes, Jitendra. Jitendra, I have unmuted you from my side. Jitendra, check your audio connection. I cannot hear you. So Jitendra, the only thing I can do here, see, I've been repeatedly telling you, if you keep on sending this message, if a message is not delivered to cloud, please check your hardware connection. The hardware connections are here on my screen. I've shared code with you. Make sure your hardware connections are proper, then only code will work. And please get your, just replug your audio because I'm not able to hear anything from your side. Okay. Sure. Okay. And don't get don't panic because we can even help you later to perform this exercise. The more important part here is to understand the logic behind the code and is your circuit working. Okay. So guys, just to allow some time to those who are still working with the circuit and code, I'll keep the circuit diagram open on my screen and we are going to have a break of 15 minutes. Post break, we'll explore other applications on Thinkific Cloud to learn building end-to-end solution. Okay, I'll help you understand that logic post break. Okay, so let's have a quick break of 15 minutes. Jitendra, to see your data, to view your data on Thinkific, go to your channel page, go to private view, you will see this graph. Okay. Got it, Jitendra? Okay. Go to your Thinkific, log into your Thinkific cloud platform, go to your channel page, and here you will see channel states as well as your data being plotted, even logged. Okay, guys, so I'm keeping the circuit diagram open and let's have a quick break. Okay, I'm running a timer on my screen. We'll resume session exactly after 15 minutes. Enjoy your break, please. Okay, guys, break is over. Shall we resume session? Guys, break is over. Are you back to your desk? Guys, please respond. Are you back to your desk? Can we resume the session? Okay, thank you. Thank you. Okay, so you know what? Let me first help you understand. You know what is our next step. So what we did over here is we built, this thing. Srinivas, to show that output, I will have to re-upload my program. You know? Let me just do it and just hold on for some time. I'm re-uploading it. Okay. Okay. So guys, what we built just now, we built a sensor node, right? We built a sensor node, and we connected this sensor node to a cloud platform, ThinkSpeak. Now, the application we are using on ThinkSpeak is a channel application, right? The application is channel, and this channel application collects data from us and plots this data for us. Okay, so it collects, logs, and plots data for us. Okay, so the operation channel is performing for us are, collect, log, and plot. Okay, this is what channel is doing for us, right? So channel is one of the application on cloud. Now cloud has many other applications. This thing is cloud. If you go to apps section, in the apps section you will find many other applications, right? So there are applications to deploy analytics on your data, and there are applications to generate actions. Okay, ThinkTweet is an application which would allow your device to be connected to Twitter to send alerts. And similarly, there are other applications over here on apps page. Now, what we are going to do, I explained you SaaS model of cloud computing. Software is a service. These applications or softwares are available to us. For example, React, TalkBack, ThinkHTTP, ThinkTweet, Time Control. These softwares are available to us as service, right? And what we can do, these components are, the software or apps are configurable. First thing, these apps are configurable, and second thing, these apps are integratable. Okay, configurable and integratable. What you can do, you can integrate them or connect them to each other to build a larger solution. And this is what we're going to do. Okay, we'll configure React to monitor our channel for an upper threshold and a lower threshold. We'll define those limits. If our data crosses those thresholds, and data which is being uploaded on channel, if the data crosses the threshold, React will generate some trigger. Now what to do next, let me help you understand that. Okay, so what we will do, we'll see this application, it is we can create multiple instances of this application. Okay, so what I'm going to do over here, I'll create 2 instances of React. Okay, 2 instances of React. Okay, React instance 1. Okay, what will this do? Instance number 1. Okay, so React instance 1 will monitor the channel for an upper threshold. Okay, and will define upper threshold is 25. Okay, the condition will set here is if temperature data is greater than 25, then generate a trigger. Okay, so what is React function going to do? It will monitor the channel at any point of time. If the value which is getting uploaded over here crosses this 25 degrees Celsius limit, React instance 1 will generate a trigger. Okay, similarly will create another instance of React, and the second instance will monitor the channel for a lower threshold, and that lower threshold is less than okay, so numerical value is same, the conditions are different. So the condition over here for React instance 2 would be less than or equal to 25. Okay, so whenever temperature getting uploaded on our channel crosses this limit, second React instance will generate a trigger. Is this clear to all of you? First React app will monitor the channel for this condition. Second React app will monitor the channel for this condition. Is this clear to all of you? Okay, now next, once this is done, we will create a command repository. Okay, so what are we going to do? We'll create a command repository. Okay, see, I'm just making this entire process simpler to all of you. We'll prepare create a command repository. Okay, and this command repository will hold command for commands for our control node, and this we are going to create this command repository using talkback function. Okay, the application name is talkback. Okay, see, talkback is the application over here, and what does it do? It queues up commands for your device. Okay, so what we'll do, we'll connect one more microcontroller. Okay, we'll connect one more microcontroller to this command repository to read commands stored over here to generate some physical action. Okay, so the node over here, we are going to call it control node. Okay, this will be our control node. Control nodes, see, there are 2 types of IoT endpoints. The IoT endpoints which are deployed in the field to collect data. This type of IoT nodes are called sensor nodes, and there can be another type of nodes which are deployed in the field to generate some actions. For example, a microcontroller responsible to control your room lights, it's going to be called a control node. Okay, so we'll have a control node, and this control node is going to be connected to this repository to read commands from here, and based on the commands it retrieves from the command repository, it will generate action. Okay, Now these commands are going to be updated. These commands to generate physical action over here are going to be updated by triggers generated by React instance. Okay, so we'll use one more app, and that app is Think HTTP. What does Think HTTP do? It simplifies device communication with web services and APIs. So Think HTTP actually it acts as a glue. It will help us connecting this React instances with this command repository. Okay, so we'll create two instances of Think HTTP. Okay, one instance will receive trigger from React number 1. Okay, and this Think HTTP instance, let us call it Think HTTP instance 1. Okay, this instance will send a command update. Okay, it will send a command update, let's say LED on. Okay, this will send a command update LED on to this command repository. Getting idea? It will send this LED on command update to command repository. Okay, the second Think HTTP instance here, Think HTTP instance 2, it will send a command update, a command string or update LED off to command repository. Okay, so repository will store one command, either LED on or LED off, and that command is going to be updated dynamically, by a trigger generated by React. Okay, getting it? Okay, so whatever command, the command which is going to be here, the command would either be LED on, the command will be either LED on or LED off, right? LED on, or let me reduce font size. Okay, so this command would be either LED on or LED off. Okay, and this command would be finally retrieved by this control node, and this control node will control a physical LED. Okay, this control node will control a physical LED. It would turn that LED on or off based on the command retrieved from this talkback command repository. Okay, so this is going to be an end-to-end solution. Data coming from our sensor node will be monitored in real time by React instances. So this is an example of a real-time analytics. Okay, the condition over here once become true will generate triggers for Think HTTP. Think HTTP instances will send command updation triggers to command repository. This event will update command from off to on. This event will update command from off to I would say on to off, right? These commands are continuously going to be monitored by a control node, and this control node will trigger a physical action based on the command retrieved from the repository. Okay, this is going to be an end-to-end solution building on a cloud platform. I hope this is clear to all of you what we are going to build now. Any questions from you guys? Yes, Ajay.
This LED control is physical LED. You mean that LED available on our Arduino board?
Yes, you can control you can control anything. You know, it's not just LED. See, we are using LED to indicate that yes, action is being generated. You can easily connect actual room light with a microcontroller, okay, or
Yeah,
your
I
door
understand
or
that.
any other physical device,
Yeah.
right?
So here you mean the LED of our Arduino board.
Yes, okay.
Fine.
And in fact, now this time, as a control node, will not use Arduino as a control node. We'll use Node MCU as a control node. Okay, so that will help you, learn a
Okay.
new platform. Node MCU, which is equally popular amongst the IoT device designers, right? Especially for
Yeah.
POC projects.
Yeah. No, why I am asking because now presently Arduino mode is sending data to the cloud. Can it
Yes.
also receive data from the cloud in the same setup?
Yes, yes. So either you can have the sensor node and control nodes, two microcontroller playing the role independently, or you can have a single microcontroller, doing both the things, uploading data as well as reading commands from the cloud,
Oh, okay.
right? But anyway, we'll use two separate microcontrollers doing this just to avoid confusion.
Hmm. Hmm.
Okay. Okay, guys. Vigneshwaran says exactly because this resembles a smart home model. Exactly, yes, Vishwashran. Uh, okay, because you know that if you connect a real room light or any other plans with microcontroller that involves working with 220-volt power supply, be that could be dangerous, because not all participants would have the experience to work with 220-volt power supply. So this is the reason why we avoid performing those kind of experiments. I'll share a diagram with you. With the help of relays, we can easily control home appliances. Okay, so I suggest you to involve someone who comes from electrical background to perform experiments. Involving 220-volt or power supply or higher, power supply, which could even be dangerous. Okay. So anyway, here I'll just show you the actuation part, this controlling part, with the help of onboard LED of Node MCU microcontroller. Okay. So here, as a control node, we'll use Node MCU microcontroller. Let me show you this microcontroller which is there in our kit. And good thing is with that you do not need to interface external Wi-Fi module. Why? Because this microcontroller comes with on-chip Wi-Fi capabilities. Okay. So this is our microcontroller module. We are going to use Node MCU is our control node. Okay, right? So Arduino is acting as a sensor node. Node MCU will act as a control node. This is how our entire logic is going to work. So let me first save this diagram because we are going to need this most probably in future sessions too, most probably in the next week session. Okay, so end-to-end cloud solution. Good. So shall we start? From where to start? So the first job here is to create a talkback repository. We'll create a talkback repository, and then, if time permits, we'll configure our Node MCU, or else I'll share a document on LMS, to help you guys configure and prepare your computer for this prototyping board, Node MCU. Okay, so to extend support to Node MCU, you will have to install a driver on your computer, and second thing, you'll have to install some library files on your Arduino IDE, and we are going to use same Arduino IDE, same programming language to program Node MCU. So you don't need to learn a new programming language for that. Okay. Now let's to build this end-to-end solution, we'll have to configure and interlink, all the components one by one. So we already have a channel. We have our sensor node connected to it, uploading data. Now let us go to the other end and create a talkback repository. Srinivas, hold on. You're still, interested in seeing my output. Okay, it's here. Do you see this, Srinivas? Okay, data is being uploaded. I'm getting a connected to cloud message. Is it okay, Srinivas? Okay, thank you. Okay, so let us first create a talkback repository. Okay, I'm sharing sequence of steps that you will have to follow to create a command repository on this cloud platform. Okay, just hold on, please. Okay, this is to set up. Okay, so this is to configure TalkBack app to build a command repository to control remote node. Okay, a control node. So we'll first create a TalkBack repository and then we'll connect this control node. So please do one thing. Follow this instructions up to this step. Save TalkBack button. That's it. Okay. I'll keep this document open here in my screen. So no need to do anything else. Just follow the instructions up to this point. So I'll just keep the instructions which are supposed to be followed here on my screen. On your ThinkSpeak cloud platform, go to apps section. Let me guide you by opening this on my ThinkSpeak channel. Where is it? Okay, so I'll just have to re-log in. Okay, so on ThinkSpeak, you go to apps section. Okay, and in the app section you will find TalkBack. Click on TalkBack. Yeah. Then you'll see a green color button. Click on TalkBack app and then click on green color new TalkBack button. Okay. When you click on this green color new TalkBack button, a new page will open, a form will open. In this form, assign a name to your TalkBack channel. You can assign a name of your choice. So I can assign it a name, TB2511. Okay. Eve. And then click on add a new command. Nothing else. Okay. Put a position number 1 and command string LED on. Okay. So the default command we are storing over here is LED on. Let me know once you're done. Okay, Sarthak, Vigneshwaran. It can take, Surendra, it can take anything, but I'm just keeping it simple because on the NodeMCU side, we'll have to program this strings, because NodeMCU will read this string and will make decision based on them. Okay, so please keep it as simple as possible. Okay, otherwise your NodeMCU's code will become more complex. Okay. So once this is done, click on Save Talkback. When you save Talkback, a Talkback channel will be created, and this Talkback channel will just hold one command. This command string is going to be there, command ID is going to be there, and a channel will have a Talkback ID, a unique ID. Is it done? I hope we all are on the same page. Okay, so now see, once you have created your Talkback page and have stored a command in it, you will see few example API endpoints over here. And this API request would allow you to work on your Talkback channel, on your Talkback repository. For example, this API will help you add a new command in your Talkback. Okay, this API will help you retrieve or fetch a command from your Talkback channel. Okay, this API will use update a Talkback command. This API will tell your Talkback repository to execute the next Talkback command. Okay, out of this API endpoints, the most useful at this point of time is get a Talkback command, because this is the API which will help you retrieve command stored in your Talkback repository, right? What this command can easily be retrieved by sending this request from a remote computer. Okay, so please do one thing. From your get a Talkback command command box, copy this URL except get keyword. Okay, we'll test this request first manually, and then we'll put this request on NodeMCU, and we'll program NodeMCU to send this request to this Talkback repository on Thinkific Cloud to retrieve command stored in it. Okay, so please do one thing. Copy this end-to-end. Copy this entire URL. Open a new web browser. Paste it in there and then hit enter. At first, you will see this error. Just let me know if you see this error. Let me know. Okay, you got the error, right? Okay, so now do one thing. If you got the error, it means there is something wrong with our request. Okay, we'll have to rectify that problem. So to rectify that problem, you do one thing. Go to your Talkback page, go to your commands table, copy command ID from there, copy this number, which is command ID from there, go back to your request, replace command id.json with the actual command ID you copied from your page. Okay, replace command id.json with actual command ID that you have copied from there, and send the request once again. Let me know what you get from there. Okay, so Vigneshwaran did this, and as a response, TalkBack repository sends LED on message, right? Yes, so this is the key, right? The command is stored in TalkBack command repository can be retrieved by sending this URL. I'm getting an error. Why? Because by mistake I deleted that question mark. So I'll put the question mark once again. You see, as a response to this request, Cloud sends this message. Okay, and now we can like put this request, the request that is tested manually. Just keep it handy with you. Okay, I would suggest you to copy this request and save it in a notepad document. Okay, put this request in a Word file or notepad document for future use. Okay, because in future we are going to use this request. Okay, so just keep this request handy. Okay, because this request is is the URL which is pointing that command stored on your ThingSpeak cloud. Okay, and let us prepare our Node MCU microcontroller, because we have got 40 minutes time, and that is more than sufficient to complete this exercise. Okay, so I'm sharing another steps with you to help you configure your Node MCU microcontroller. Okay, to read this command from your command repository. Okay, so this is your Node MCU microcontroller. Please take it out from your kit and use a USB cable. You can even use your mobile phone's USB cable. So I'd suggest you to use mobile phone's USB cable instead of the cable provided in the kit. Okay, but do not connect this board to your computer now. First, we will install drivers on your system, and then once drivers have been installed, we will install libraries in your Arduino IDE to extend Arduino IDE's support to this board. Okay, so please do one thing: follow the instructions given in this file. Go to this link to download a driver from there. Yes, Ajay.
Shafi, because this exercise involves a lot of documentation, and currently I myself and maybe few other contestant participants attending from the phone. So please ensure these documents are available on LMS. Okay.
Yes, I already dropped a message support team. All these documents will be available on LMS. Okay.
And everything, including yesterday's. Okay?
Yeah. Yes. Sure. In fact, all these. Yes, this is the reason, because these are complex solution building exercises. This is why we have documented it properly, and all these documents will be shared on LMS. Don't worry. Okay, Jay. Okay, guys. So the first thing, we'll have to download this driver file from this Scilab website. Okay, because Node MCU board comes with a chip, Node MCU board. If you look at your Node MCU board, yeah, I'm sharing URL, but let me first help you guys understand why do we need this driver. Because see, Node MCU board has this chip. If you look at your board, you'll see the square shaped chip, right? This chip, this IC. This is USB to UART driver. USB to UART, and this USB, whatever comes from your computer, it's going to be converted into UART protocol by this chip. So the driver we are going to download is for this chip, to enable your computer to recognize this chip. Yes, this is from Scilab. Okay, so the chip's number is 210X. Okay, and driver you can easily download from Scilab's website. Okay, I'm going to share this link in the chat window. You can download drivers. So for example, for Windows 10 users, link number 1 will work. You just go to this page and click on this download VCP 2.3 MB. Okay, so for Windows 10 people, download this VCP 2.3 3 MB. For Windows 7 and 8 people, you can download the file by clicking over here. For Mac OS users, you scroll down and you will see a Mac OS compatible driver file here. Okay, when you download this driver, you would find it's a zip file. Okay, and this zip file contains exes. Okay, the zip file contains exes. When you open the zip file, you will see exe file. So I would suggest you guys to run this exe file, x64, to install the driver. Okay, so we're installing this driver to detect the chip mounted on Node MCU board. Before you connect your board, this is mandatory. Okay, driver installation has to be done. Okay, let me know once you're done with driver installation. Okay, Jitendra, let others complete. Okay, Mahesh. Okay, those who have completed driver installation, they can move to step number 2. Okay, step number 2, 3, and 4. What is step number 2? Follow the instructions given here in step number 2. So these steps are required to install libraries on your Arduino IDE to extend support to Node MCU board. See, Node MCU is really interesting board. It comes with on-chip Wi-Fi. It's based on ESP12E chip. ESP12E is actually a Wi-Fi SoC with on-chip TCP/IP. It is you can so ESP01. It's an advanced version of ESP01. ESP01 and ESP12E both belongs to same family. For Windows 7 and 8, I don't exactly know, Rakesh, because I haven't explored this. Maybe you can click on learn more to find more information about this, because Windows 7 and 8, hardly people use Windows 7, 8 nowadays. Most of the people use Windows 10, right? So I don't exactly know. I will have to go through this link. Okay, so I'd suggest you to read the information provided over here. Yeah, the question you're asking me has been answered here, right? Jitendra, yes, the URL, hold on, all the instructions are given over here. In Arduino IDE, go to File Preferences and paste this URL in Additional Board Manager box, then click on OK. Do you see this, Jitendra? All the instructions are given here. Please follow the instructions. Okay. So on your Arduino IDE, when you open the Arduino IDE, you go to File, then Preferences in the File menu. Okay, a box will open, and in Additional Boards Manager URL, you will have to paste the URL that I shared with you. No, Rakesh, there wouldn't be any change except the driver file. There wouldn't be any change except the driver file. Okay. So guys, this is the box where you need to paste URL. I did paste this URL in chat window, Rasuri. I'm doing it once again. Okay, so this is the URL from HTTP onwards. Okay, paste it in that Additional Boards Manager URL box. Okay. Okay, Vigneshwaran. Okay, so once this is done, click on OK. Then go to Tools, Board. At the top, you will find Boards Manager. Okay, click on Boards Manager. It will open, it will give you a search option to search for your boards. So we'll search for ESP8266, and you will see ESP8266 by ESP8266 community version 2.4.2. In the search list, select that option, select the latest version, and click on install to install these board files to extend Arduino IDE's support to your Node MCU microcontroller board. Okay. Okay, who was raising hand? Could you please raise again? Yes, Rachuri.
Actually, in the tools menu, there is no boards manager, but I
See, in tools, go to boards. Tools, go to board.
provide the
Okay,
board. Yes, it is board.
and then you see in the list of the boards, you see an arrow pointing upward.
Okay, 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 okay.
Do you see boards manager there? See, look at my screen.
Yeah. It is there.
Okay, click on it. It will open this boards manager search page, right?
Yes.
So here in the search box, type ESP8266.
Yes. There is a board included in this package. This is going asking to install.
Pardon?
This is asking to install.
Yes. So select it, select the latest version, and click on install. To see this ESP8266 by ESP8266 community board.
Yes, it is there.
Yeah, select latest version, click on install to install this drive, these files, board files. Okay.
In this 2.2, 2.42 is the latest. 2.41 like that it is coming.
2.4.2 is the latest.
Yes. So
Okay, select it and install. Okay, guys, installation may take some time. See, installation may take some time. So let me do one thing. While your files are getting installed, let me show you how your NodeMCU board will work. Okay. Or what do you think? Should I wait for you to finish this thing? Yes, Lokendra.
Yeah. So, hello, are you able to hear me?
Yes, Lokendra.
Yeah, my question is about the step two. So in a step two, we need to connect this Arduino board ID to the laptop, and after that we perform this steps.
Not Arduino board. Arduino
Yeah.
IDE.
Yeah, Arduino ID.
So
So
Arduino IDE means the software, Arduino software.
okay,
No
first
need to
step I
connect the
have
board.
completed. Yeah, first step I have already completed. It is
Okay.
successfully installed.
So for
Okay.
step number 2, you don't need to connect any board. Just follow the
Okay.
instructions. See, the first line
File
says
preference.
in Arduino IDE.
Yeah,
In
Arduino
Arduino
ID.
IDE, go to File Preferences. In Arduino IDE, go to File and
Uh,
Preferences.
just a
Right?
minute. Some issue. I think so.
Open your Arduino IDE.
I'm opening the Arduino ID, but it is still hang mode. I don't know why. Let me check. So first we need to remove this first step ID, right? I have already installed this driver.
So driver installation is the step number 1. You
It
have
is done.
completed that, right?
Yeah,
Okay,
completed is
now
connected.
go to step
So
number
first,
2.
before go to the step number 2, then we remove the device, right? First one.
Have you connected your board to your computer?
Yeah, it is connected.
So anyway, unplug it right now because there's no need to connect it. Just unplug it.
Okay.
Okay. And
Okay.
complete the step number 2 and then follow step number 3.
Okay. 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 Okay.
Follow step number 2, Lokendra, and let me know if you face any problem. Okay.
Sure, sure.
Sure. Guys, those who have completed step number 2, they can move forward to step number 3. They can now connect their board to their computer and find out the port which is going to be assigned to your board once it's connected to your computer. Okay, so please complete step number 2, step number 3, step number 4. Step number 4 is to upload a test program on your NodeMCU. This program is LED blink. This program is to blink the onboard LED of your NodeMCU board. This is just to test your boards and its configuration. Okay. Yes, Raj Surya.
Yeah, yeah, sorry to ask this one. Actually, in this app talk, that one, once I am copying the URL and pasting that, it is showing that this page is not working. That API keys URL, can you go back that night? Because it is going on installation right now, this one.
Which URL? This URL?
Not this one URL. Before that, things speak, in that things speak, from the APK.
No, so why are you still working on that?
No. Actually, that you got error, na? The same error I will getting it. So you say that it will show something, but I am not creating that node itself in that page. There I skip to that one.
You're facing problem with your with connecting Arduino to ThinkSpeak as a sensor node, right?
Yeah.
The previous exercise.
Previous exercise.
So Raj Surya, forget it at this point of time.
Okay, this is new. This is Wi-Fi board.
This is new exercise. So don't worry. We'll sort out this problem. We can sort out this problem later. Let us focus on this part right now. Have you completed the driver installation?
Installation is over. That what is that?
Which one?
The second one is going to install.
Okay. The files are getting installed, right?
Yeah.
Okay, so as soon as it completes, please move to step number 3.
Yeah.
Okay. Guys, let me know once you are done with all the steps. Vigneshwaran, it depends on your network speed. So just wait for it to finish. See, the library installation depends on network speed. If you're on a high-speed network, it would complete quickly. Okay, so Chandrasekhar has started flashing. Okay, in fact, Chandrasekhar, you have completed all the 4 steps, right? Okay, who else has completed all the 4 steps? Is anyone else who has completed all the 4 steps? Okay, I'll wait for you guys to finish. Don't worry. Okay, for Jitendra, compilation is going on. Okay, LED is blinking. Good, Jitendra. Okay, so those who have completed, okay, for Mahesh also it's been completed. Okay, so if you have completed step number 3 and 4, for those who have completed step number 3 and 4, I'm going to share a link in the chat window. Okay. On this link, you'll find a code to program your Node MCU to read this command from your TalkBack repository, whatever we discussed earlier. Yes, Loken Singh.
Yeah, it is same issue. I am going for the install this link. A link is added in preference, and after that I'm going to the board manager and type the ESP8266 in search word. It is not showing nothing.
Okay, first thing,
It is
you went to preference, right?
yeah, went to
Yes.
preference.
Did you paste this link in the additional boards manager URL box?
Yes. Go to the
Verify it once again.
preference. Yeah,
Yeah,
additional board
preferences.
manager URL. I paste it once again and put it okay, right?
Yes. Okay.
Just look.
Okay. Once again, you
Okay, after
compare.
that, after go to the tool, board,
Yeah, go to
go to
tools,
the tools,
board,
board,
boards manager.
boards manager, enter.
Yes.
It is board manager is open.
Yeah. Here in the search
After
option, search for ESP8266.
ESP8266. Nothing showing.
Nothing appearing here.
Yeah, nothing.
Okay, what if you don't type anything?
Nothing. It is showing Arduino AVR board built by the Arduino version 1.623 installed.
Okay. Do you see any error at the bottom?
Yeah, it is showing error downloading HP downloader Arduino CC/package/package index.json.
It means there is something wrong. There is something wrong. It's not able to reach to see. The same thing is happening with me. Your Arduino ID is not able to reach to the site. Download files from there. Maybe
Okay.
because of some firewall issues or something else.
No,
Do
no, no.
any
It's there.
antivirus?
Yeah, antivirus is there.
Oh, it may be because of some antivirus or firewall issues. Okay. So I would suggest you to just disable that antivirus or if you have any firewall on your system, disable that firewall for some time
Because
to allow.
I'm using the company-based laptop.
Yeah, that might be the problem. Because most of the time this laptop comes with firewalls. Even my laptop also has firewall. So this is the reason why I face this type of problems.
Okay, okay. Then what shall I do?
No other option because those files are needed for to support NodeMCU. There is no other way. Okay, so you'll have to contact your IT team to help you sort out the issue. Okay, Logan, don't worry. These documents are going to be there on LMS, right? So you can perform this exercise at any point of time. Okay, Logan.
Okay, what's
Okay,
I'll
okay,
try
okay.
it.
Okay, guys. So those who have completed all the 4 steps, for you, I'm sharing this code. Okay, Shahrukh, if port comes disabled, I'd suggest you to change the cable. Use your mobile phone's USB cable, to connect NodeMCU to your computer. Are you using the cable provided in the kit? Okay, so if port is coming disabled, problem the problem is with either with the cable or with the driver file. Okay, so please check your driver installation once again. Second thing, check your cable. Okay, now those who have completed all the 4 steps, the code is with you, right? I have shared link in the chat window. In the code, you will have to make some changes. Okay, the first change you will have to make is here in this line, Wi-Fi multi.add AP, replace this with your SSID and the second parameter with your password. You put your Wi-Fi credentials here, your Wi-Fi SSID and Wi-Fi password. Okay, here. See, I'm giving the instructions to them who have completed all the 4 steps. Vigneshwaran, the port will appear with name CP210X Scilab USB UART, something like this. In Device Manager, you will see a port, with the name CP210X written in front of it. Okay, Shahrukh. Okay, Vigneshwaran. Please check. I would suggest you to, change your cable, Vigneshwaran. If it doesn't get listed over there after driver installation, I would suggest you to check your cable. Okay. Guys, those who are working with the code, this code is to program your NodeMCU to read stored command on your ThinkSpeak TalkBack repository. Okay. Have you made this change? First change? Drop message in chat window. If you have made this first change in the code, say yes or no. Okay. So now next change that you need to make is inside http.begin method. Do you see? http.begin method. Okay. So here you will have to replace this part of the code with the URL that you tested earlier. Okay. The URL that you tested earlier. Okay. The only thing that you will have to do here is do not put S in HTTP. Okay, when you paste the URL that you tested earlier to read the command string manually, put that URL here, but make sure you remove S from here. Okay, where to put? Inside http.begin call. See, scroll down in your code, go to this section, http.begin, and make this change. After making this change, upload your code on NodeMCU board. Okay. Got it? नहीं.
The API number changed. Can you repeat it about last changes?
See the URL that we tested earlier, right? To read the command from repository. Is that URL with you?
No, that's not. That is not. This is what we are logging in that ThingSpeak, na?
On ThingSpeak, we use a URL to read command from the command repository.
Yeah, that is in the add talkback command.
Yes, I asked you to keep that URL stored, saved in a Word or Notepad file. You have that URL with you?
Yes, that URL I have.
Okay, copy that URL. Okay, and replace this URL inside http.begin call in your code. Okay. Inside http.begin call, you have a URL, right?
Yes.
Replace that URL with the one that you tested.
Okay.
Okay. Do not forget to remove S from the HTTPS.
Okay.
Remove S, and then you upload the code.
Okay. I will change this one.
Yeah, upload this on your microcontroller. So we are programming NodeMCU board to read commands from there, right? Okay, so once code is uploaded, open your serial monitor. Keep baud rate 115200. Yes, Vigneshwaran. Vigneshwaran.
Hello, can you hear me, sir?
Yes, I can hear you.
Okay, sir, I have changed the cable for the ESP8266 with a different cable from what was not from what was given in the kit, and even after that, I'm not able to find the ESP8266 port in the device manager. Just COM1, COM2, and print report. That's all is that is available here.
See, let me show you my device manager.
Okay.
Okay, so in device manager, you will find this port listed under list of COM and LPT ports, right?
Exactly, that is where I'm looking at.
And this port will have Silicon Labs CP210X USB to UART bridge, this name.
No, it is not available.
If it's not there, then it means there is something wrong with the driver installation. I'd suggest you to repeat driver installation once again.
Okay, I actually did it the second time and installed completely. And I just
Then in
any
that case, the
that would
second problem could be your cable.
okay.
You know,
Is there
that's
any
just
LED light that will come up on the ESP8266?
on NodeMCU board. Yes, blue color LED will glow.
Just after the cable is connected to the computer.
Yeah, when you connect the cable.
But there is
Okay,
no such
see,
light.
what happens? Most of the cables that comes with mobile phones, USB cable comes with 4 wires, right? Most of times, the cable that we use with mobile phone chargers, they come with only 2 wires, power supply wires, no data wires. Okay, so
Let me check that. Let me check with
yeah,
another
that is the
cable.
problem. If data wires are not there, your board is not going to be detected, because data wires are the wires which are going to be detected by your computer to activate the driver. Getting idea?
Okay,
So
no
I'd
problem.
suggest
I'll
you
check that.
to try this out with another USB cable. Try to find a data cable with all 4 wires have to be there. Okay.
No problem. I'll check that. No problem.
Okay.
Thank
Okay.
you.
Sure. Okay, so those who have uploaded the code on their microcontroller, open serial monitor, keyboard rate 115200, okay, 115200, and you will start seeing these messages. Do you see any message over there in the serial monitor? Okay, Jitendra, are you getting LED on message? And is your LED on? NodeMCU board LED is on. Okay. Let me show it to other participants who are performing this exercise. Just hold on. I will have to re-plug my webcam. See, as you guys see here, those who are performing exercise, because we are running short of time, so I'll give it to you as an home assignment, and we can have this exercise repeated in the next session. So don't worry. If you are not able to complete it now, what I'll do, I'll repeat this exercise for you in the next session. Okay. So as you can see here on my NodeMCU microcontroller, the blue color LED is glowing, right? The blue color LED is glowing. It's difficult to keep it still. Okay, blue color LED is glowing, and the command string being retrieved by my microcontroller is being printed here, LED on, right? In the serial monitor. So I'll do one thing. I'll simply go to my TalkBack repository. Okay, and on TalkBack repository, I'll change command from on to off. Okay, so I'm keeping both, in fact, all 3 windows open. Okay, my webcam, the serial monitor window of NodeMCU, and let me go to where is Shahrukh. It takes time, first time uploading takes time, because it will have to fetch all the libraries. I'm really sorry, it's difficult to keep so many windows open on laptop's screen. Okay, so I'll go to my TalkBack page, and on TalkBack page, there is an option to edit command. Okay, there is an option to edit command. So I'll click on edit TalkBack to modify command from on to off. So keep looking at my all those who are performing exercise. Please look at my serial monitor, guys. Just look at my serial monitor. See, right now my LED is on, as you can see on my webcam. NodeMCU is reading command LED on. The moment I update this command here on my TalkBack, Node MCU's LED turns off, right? The command has been retrieved by my Node MCU application, and Node MCU's LED is turned off. Okay, when I make any command, any change here, the updation from off to on, the LED of Node MCU will be switched on by Node MCU, and when I change the command from on to off, okay, the LED will turn off. Okay, is this happening with you guys? Those who have completed the code, those who have successfully uploaded code? Okay, so working for Chandrasekhar. Mahesh, what is the problem you're facing now? Vishal, I'll suggest you to unplug your board, close your IDE, plug your board first, and then open your IDE, and after that try uploading code. Okay. Mahesh, do you see any message in serial monitor? Okay, do one thing. Your microcontroller board has a tiny button, reset button next to USB connector. Press that reset button once. Mahesh, can you hear me?
Yeah. Yes, Shafiq.
Do you have did you set baud
Yes.
rate to
I
11.200?
I get some garbage. After that, it's telling setup wait 3, wait 2, wait 1.
Okay, so it's getting it's trying to connect to Wi-Fi.
Yeah.
Okay, what do you see now?
I stopped there. Oh, then it's a Wi-Fi connection issue.
Yes. So if it stops there, it means it is not able to connect to Wi-Fi. See, mine is also reading, right? 3, 2, 1, and then it says begin, right? You see
Yeah.
that begin thing is not appearing, right?
Yeah.
It means the problem is with Wi-Fi settings. So you go back to your code, check your Wi-Fi settings here in the Wi-Fi multi.aid AP line.
Okay.
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 Make sure you have put your SSID here, the first parameter, and your password is second parameter. Okay.
Okay. Okay. I checked that.
Yeah, please check and re-upload the code, then try same thing once again. Okay. Okay, so I hope I just demonstrated what we are trying to achieve over here. We are trying to build this TalkBack repository to store commands for NodeMCU. And as I explained here with the help of this diagram, your NodeMCU, we have connected NodeMCU to read these commands from TalkBack. We are updating this TalkBack commands manually right now, as I demonstrated to you. You can try it once you are done with your with all these steps. And don't worry, we'll repeat this exercise in the next session. Okay. So if you could not complete it today, don't worry. We'll have a repetition of this exercise in the next week session. Fine. Vigneshwaran, which operating system is Vigneshwaran, may I know? It's Windows 7, right? Okay, then there could be some problem, driver issues. If it's Windows 7, then I would doubt driver issues. Can you try it on the Windows 10 computer, maybe during the weekdays? So Jitendra also has Windows 7 computer, but for him it's working fine. So Yes, there is no other, because the steps I have shared it. It's everything is tested, so we cannot doubt the steps. The only problem is with only problem could be with the cable or with driver installation, right? Okay, guys. So Rashuriya, can you copy that error and share it in chat window, Rashuriya? Yes, Ajay.
See, this Silicon Labs drivers, I work with the most of the Silicon Labs drivers on Windows 7. They recommend that while installing the drivers, both should not be connected. I think this is something we have to note.
Okay, let me check with Vigneshwaran. Vigneshwaran, did you disconnect your board while installing driver?
Yes, I have disconnected.
I'm getting echo from your side. Vigneshwaran, can you hear me?
Yeah, because I am already working with several CP Silicon Labs drivers and with Windows 7, and I don't find any issue. They are working with Windows 7, no issues.
Okay, okay. Let me check with him once again. Vigneshwaran, can you hear us?
Yes, I can. Can you hear me?
Yes.
So I have disconnected everything, and I have reconnected the Arduino board as well. I'm sorry, the ESP8266 as well. So I don't think
no, Vignesh, you have to disconnect everything USB to UART physical boards and reinstall the drivers and reconnect them. While installation, you should not be
connected. Yes, that is what I've done. While installation, I didn't connect anything to the computer. The only thing that was running.
Vigneshwaran, you know, sometimes Windows system requires a power restart, you know, for driver installation.
I think I'll have to try that. No other option.
That is the last option, right?
No problem. I shall try that, and I can refer to LMS next time.
Sure. So you can always approach us to us, you know, if you on any weekday, whenever you find time. Okay, Vigneshwaran? Okay, thank you, Ajay. Okay, so code, the link to this code that I tested on my NodeMCU is already shared in the chat window. I will, you know, help you once again with this code, and I will help you understand the logic. The code has lots of comments anyway. So give it a try during the weekdays. If it works fine, if not, don't worry. We'll have a reparation. Okay, as I said. So yeah, Vigneshwaran, I'll share the procedure. Sure. So guys, okay, I'm sharing code once again. Starthak, just hold on. So it's just two things in the code. First, you will have to change. Let me show it in the code itself. You will have to change this thing. Your Wi-Fi SSID and password here. So the first parameter has to be your SSID name. Second parameter has to be your password. Okay, and second change that you will have to make here is here in the http.begin line in this part of the code, which is request to TalkBack repository to retrieve the command stored over there, right? So replace this link with the link that you tested manually to retrieve command from the TalkBack repository. And do not forget to remove S from the HTTPS. Make it simple, only HTTP. Okay. These are the two changes that you need to make here in the code. Upload the code on your NodeMCU board. Keep the baud rate 115200. Okay. If you don't see any message, press a reset button on your NodeMCU once, you know, which is next to your USB port. Okay. You'll start seeing the messages in your serial monitor window. the message, whatever command you have stored on your TalkBack repository, this command will be printed over here. Okay, so this is the procedure. Try this out and let me know. We can have a discussion on this in the next session. Okay, Rasuri, I'll just take last question and then we'll wind up.
This is the last question. Just show me the URL where you are copied from. That I am mistaken there only.
Okay.
No, not in the code. Not in the code. Just go to the ThingSpace website, please.
Okay. The URL that we tested, we took from here.
One moment. Let me copy. Yeah.
Get a TalkBack command.
Oh shit! I copied the top one command.
No. The first one, and after copying this URL, copy this URL, put it somewhere. Okay, and then replace command id.json with actual command ID from TalkBack page. Okay, actual command ID. Put this over here. Okay. Okay. Once your URL is tested, copy this URL. Okay. Put this URL in your code. Do not forget to remove S from there. Right.
Okay.
That's it.
That's okay. I got it.
Okay, fine. Okay, guys. So thank you very much for this interesting session. See you next week with more exercises. Okay. Have a nice weekend. Good night.